Hello, good afternoon. Am I audible?
Yes, ma'am.
Hello, sir. So I'll wait for a few more minutes. If someone else joins, then we'll start. Is it fine?
Yeah.
Okay, I'll start sharing my screen. Please let me know if you can see. Is my screen visible?
Yes.
Okay, so I'll start now. Good afternoon. I am ShreyaChakraborty. I am a PhD student in IISc Bangalore and I am the TA for this course. So today I'll be solving a few problems related to simple linear regression. So before starting, I would like to know if every one of you has followed week 1 lectures or not. Is there anyone who has not got the chance to go through week 1 lectures?
Yes, ma'am. Just joined today.
Okay, you just joined today. Anyone else?
Yes, ma'am. Me too.
Okay. So, the problems that I'll be solving today, the formulas that I've used, I will be using those derivations have been done in week 1 lectures. So I had this idea that you would be acquainted with it. So once I finish, and if you are unable to understand, if I don't think I'll have the time to do the rigorous derivations, so please go back and check week 1's lectures. Okay, I'll try to explain as much as possible, but if you haven't followed it, please go back and follow the lectures for the detailed derivations. Okay.
Yeah.
Okay, ma'am.
Okay, so I'm starting. So today we'll be talking about simple linear regression. So just as a recap, any idea what do we mean by regression? Anyone? Anything, you can be frank. Yes. No one?
Hello.
This is
Yes, sir.
Regression is basically a relationship between dependent variable or one or two more independent variables.
Okay,
no.
so you are
This is the
saying
fitted line to represent the relationship between the dependent and independent variables.
okay, so dependent and independent variables. So can you give an example and say which is dependent and which is independent?
So,
Hmm? Suppose I give an example.
Suppose
Okay,
there is a sales and advertisement.
okay,
So sales is depend on advertisement. So sales is a dependent variable and advertisement is a independent variable.
okay. Now, if I give you a situation, let's say rainfall and yield of crops.
Yeah.
So, which one do you think will be a dependent variable and which will be an independent variable?
Yield
rainfall
of
is the
crop.
independent variables.
Yield. Rainfall is independent
This is
because
independent?
yield of crop is dependent on rainfall.
Exactly. So, by regression, we are interested in uh, judging the relationship between dependent and independent variables. Now, we are focusing on linear relationships. And what do we mean by a simple linear regression?
Only one depend dependent variables. Only one dependent variable in the case of linear regression.
Only one independent variable.
Linear variables.
So if this is my equation, then this is my independent variable and this is the dependent one. Y depends on the values of x. So let's suppose we have a set of values xi yi. So how do we visualize it? if I have a set of coordinates, then what is the simplest way to visualize and judge whether I'll be able to fit a line or not? Sorry?
The x should be some finite value. X should not be 0.
No, x can be 0. I am talking about visualization, a graphical representation. So, what is
Scatter plot.
yes, exactly, scatter plot. X and y along this axis. So, let's say if we have 1 1, if we have 1 2, then 1 1 this point here, 1 2 this point here. So, in this way we can have multiple points, and if by intuition we can see that as x increases, y also increases. So we have some intuitive idea that we can fit a line, the relationship is linear. So this is what we are going to do. Now what is the form? I wrote it in the previous slide itself. Let's say for the ith observation yi equal to beta naught plus beta 1 xi plus epsilon I, where this yi is my response or dependent variable for ith observation or individual. Xi is the independent regressor predictor, okay, and epsilon I is the error component, because we are not there with each individual there's some amount of random error associated, like the rain and crops, that example that I gave. If let's suppose in 2 years the rainfall amount is exactly same, some centimeters, but does that imply that the yield of crop will also be exactly same? No, there will be some amount of variation. That variation is captured by this EI part. So what were the, before fitting a line, linear regression, what were the assumptions on epsilon I that were taken? Mainly there were 3 assumptions. Anybody remembers?
Yes, ma'am. Epsilon I is a random variable with 0 mean and variance sigma square.
Okay.
And EIJ and EI and EIJ are uncorrelated and normally distributed.
Yes. So expectation of this is 0. Variance of this is 0. Sigma square, I'm sorry. Correlation between, that is covariance epsilon I epsilon j equal to 0 when I not equal to j. And the third one was these are normally distributed. These were the 3 assumptions. Now it's important for our error part to follow these assumptions so that we can fit a linear regression by these methods. So now once we are done with the assumptions, how do we estimate betas and how do we derive it? So here we had beta naught plus beta 1 x I plus epsilon I. So this is our model, but we need to find out the predicted value of y, let's say given by y hat, by values of x. So for that we need the estimates of beta naught and beta 1. So what was the logic and how to derive the estimates of betas? So let's say this is my line. So we were fitting a line in such a way, which of the distances were minimized, this horizontal one or this vertical one?
Vertical one.
Yes, the vertical ones, yes. So let's say this point is yi. This point on the prediction line, this one is my predicted value. So this difference yi minus yi hat, this was my residuals. So how did we derive it? We were to minimize the sum of squares of residuals. Now how did we do this? We have to find values of beta naught and beta 1 such that this quantity is minimized. So the way to do is to do partial derivatives with respect to beta naught and so these two were my normal equations. Okay. So I'll just recap. This one was summation of ei square, which means summation of yi minus beta naught hat minus beta 1 hat xi whole square. So then we got minus 2 and we are equating it to 0. So this means summation ei 0. This is one of the normal equations, and the second normal equation is so when we do the derivative, this 2 comes in front, yi minus beta naught hat, and beta 1 has as a beta 1 hat has coefficient xi, so that is also going to come here, and we are equating this to 0. So the second normal equation is ei xi equal to 0. I hope this is clear. So next I'll move on to how do we interpret regression coefficients. Let's say I have this thing.
Can you just repeat last two second equations?
These two?
Yeah, second one.
The second one? Okay. So just a second. Yes. So in order to we are to find values of estimates of beta naught and beta 1 such that this quantity here, this is minimized. So if you remember how we used to do maxima minima, we used to do a derivative with respect to that parameter, and we would equate it to 0, and then the double derivative would be greater than 0. So same logic is applied over here. So we have two parameters, beta naught and beta 1. So once we are taking a derivative with respect to beta naught, and the second one we are taking a derivative with respect to beta 1. Now come to this equation. This is summation ei square. Ei is the yi minus y hat, the predicted y. So when we take a derivative with respect to beta 1,
Beta 1.
yes, then this 2, like let's say this one, t dx of something x square equal to 2x. But if we have something here 3x square, then we would do 2x, 2 into then 3x.
3x.
Same logic is being followed over here. First we take 2, then we have this thing, the entire thing, and beta 1's coefficient is xi. We are not taking it outside because this is dependent on the sum. We just can't take it outside. But this does not depend on I, so we are taking it outside the summation sign. Is it clear now?
Yeah.
Okay. So how do we actually interpret regression coefficients? Suppose my beta 1, this rainfall example I'm giving, let's suppose for this is rainfall and this is my yield. So, and let's say beta 1 is in some units, okay? Let's say beta 1 is 1.2. So what does this mean?
It means slope of the line.
Yes, mathematically, but if you have to interpret in terms of this equation, what can you say?
It is if it is in positive sign, means it is increased by the dependent independent
Hello? Hello?
Yes, ma'am.
Yes, sir. See, if this is positive, then you say that
Independent variable regrets 1.2 times.
okay. So let's say we have some y1, which is this thing. Now we have something y2, which is also, we increase x1 by 1 unit. So if we do y2 minus y1, then we are going, this is x1 plus 1 minus x1, this is my beta 1 hat. So it represents change in y for unit change in x. So for that rainfall example, if I say that for 1 centimeter increase in rainfall, the yield increases by 1.2 units. And this one, beta naught, if we visualize like this is beta naught, which is the intercept, and beta 1 is the slope. Now there could be situations where if let's say beta naught is 0, it means that it passes through the origin x and y. So it means that if x is 0, then y should also be 0. But if there's some beta naught component over here, it means that even if x is 0, y has some some value, which is also
Sorry.
sorry. Yes, so I'm saying that if beta naught is 0, then the line will pass through the center. So then in this crop situation, it would mean that if there's no rainfall, there will be no yield. But sometimes this may be true, but sometimes, most of the times, it's not true, because even if there's no rainfall, it is expected that some yield will be there. It will not be as expected, but some yield will be there. Also, if you consider that advertisement and sales, even if you do not advertise for a product, there will be some sales. So this situation is captured by this model. Even if the advertisement is 0, there is some sales. But if it was the case where no advertisement would mean no sales, then our model could have been this one also. Am I making sense?
Yes, ma'am.
Okay. So then finally, we are so by that normal equations, and you can see the detailed derivations in the lectures, we arrive at the estimates and their distributions. So beta 1 hat, anybody remembers what it is, the estimate, what it comes out to be?
Summation x minus x bar, y minus y bar, yi minus y bar upon summation xi minus x bar whole square.
Okay, this thing. And this is a linear combination of yi. This is clear to you, to all? Why this is a linear
Yes.
combination? Yes. So since yi's, epsilon i's, we have taken, it follows normal this thing. Yi is this one. So this also follows normal beta naught plus beta 1 x and
Sigma.
sigma square. And then since this is beta 1 is a linear combination of yi's, this also follows a normal distribution with the expectation of beta 1 was beta 1. And please mute your speaker if anybody is on. Thank you. Yeah. So beta 1 hat follows normal beta 1, and the variance is sigma square by, anybody?
Indian.
Sorry.
Sigma square divided by in degree of freedom.
No. This is SXX, where S, this is something xi minus x bar whole square.
Whole square.
Okay. This is the estimate of beta 1 hat. So similarly, estimate of beta naught hat was y bar minus
beta 1 x bar.
And it also followed normal
Distribution.
It was unbiased, so beta 0, and the variance was this one. Okay, so with these prerequisites, we'll move on to solve this problem. So
And the previous slide is comma or it's plus?
which one? It's plus.
1 by
I'm
n
sorry,
plus.
I'm sorry, it's plus. Plus. Yeah. So we'll start by solving this problem. So a test is to be run on a given process for the purpose of determining the effect of an independent variable x, which is process temperature, on a certain characteristic property of the product y. So the test was run based on 20 observations. So for this problem, what is my n? Total number of
20.
observations?
20.
Okay, and we have these values given: x bar, y bar. This is my sxx. This
SX.
one is syy.
SYY.
And this is sxy. So assuming that this is the simple linear regression model, beta 1 hat would be
1 by 2.
exactly xxy by sxx, that is 80 by 160 half. And here again, if we had to find beta naught, it would be
3 minus half into 5.
3 minus half into
5.
5. It would be half again.
1 by.
Okay. So for the next problem, this was also the least square estimate of beta naught. This came out to be half. Now, what is the degree of freedom of SS residuals? So the residual sum of squares, it was given by yi minus yi hat
Y.
whole square. This is my SS residual. So the degree of freedom of SS residual was n
Minus 2.
So here n is 20 and thus the answer is 18. Now, how do we calculate MS residuals? This is calculated by
SS residual upon degree of freedom.
by degrees of freedom. So how do we calculate the SS residual?
Summation yi minus y hat whole square.
Summation xi square minus n x bar square.
yi minus y hat whole square.
Yes. So in this problem we had if we have to scroll here, where is the problem?
83.2.
83.2 is yi minus y bar. we need yi hat. So SYY was 83.2, SXY was how much? It was 80, this was 160. Okay. So this comes out to be SSY minus beta 1 hat SXX. Anybody remembers this?
SSY or SYY?
SYY, sorry. So SYY here is 83.2 and beta 1 hat came out to be half. So this is 1 by 4 into SXX. SXX is 83 point, sorry, into 160. 40, this is 43.2. This thing, it's given in the lecture notes, but if you want, I can start deriving.
Yes, sir.
It's pretty straightforward. So shall I start deriving or is it fine?
Yes, please drive.
Okay. So we are going to find out SS of residuals. This is given by yi minus yi hat. Just a minute. Yi hat is and yi is given by just a second. So this part is my SYY. Okay, this is SYY, and this part is 0 because one second, no, this is this one minus yi. Oh, this will be minus yi hat minus y bar whole square minus 2 summation yi hat minus y bar mm. Hmm. And y bar, if we do, is beta 1 plus beta 1 x bar. So this comes out as, sorry, and yi sorry, am I getting it correct? Y minus y bar plus y hat minus y bar. Anybody can find any fault over here? Okay, so yi will write as beta naught plus beta 1 xi plus epsilon I, and so y bar will be beta naught plus beta 1 x bar plus I'm sorry. Okay, I'll come back to this proof. Let me finish the other topics and then I'll come back. Okay, I'm really sorry. So then we have this, the degrees of freedom of SST. So SST is yi minus y bar whole square. And in sampling distribution there's one theorem that if x follows normal mu sigma square, then x minus mu by sigma follows normal 0 1, and then x minus mu by sigma whole square, it follows chi square 1. And summation, if all such xi's are independent, then summation of xi minus mu by sigma whole square, it follows chi square n. But summation xi minus x bar whole square by sigma square, it follows chi square n minus 1. So if we draw parallel over here, what was x? Our y variable is similar. Where is this? It also follows normal with some mu. In our case, that is beta naught plus beta 1 xi, and this is sigma square, what it used to follow. Then this one, if this follows this, then the degrees of freedom of this quantity was n minus 1. So similarly, in this case, the degrees of this one will be n minus 1. Now here n equal to 20, so the required df is 19. Okay.
Why it's in degree of freedom is less than 1?
Because you see, summation xi minus x bar, this is 0, this is a constraint. If there are n x's, you can only choose n minus 1 x's freely. 1 x will be chosen as per this constraint.
What did it explain? Degree of freedom less than 1, what you explained in this problem?
Degree of 1, yes, because of this constraint xi minus x bar. So if you let's say we always, this xi minus x bar will be equal to 0. Okay, so you can have, let's say our n is 10. So sum of all 10 values will always be 0. So you are free to assume only 9 values because the 10th value will be automatically chosen as sum of 9, 0 minus sum of 9. That will be the value of the 10th variable because of this constraint. If we simplify this one, this is nx bar minus nx bar. This will always be 0, right? So this thing has a degree of freedom of n minus 1. So in this case, our yi, which also follows normal with some mean, and this is the sample mean, this also has n minus 1 degrees of freedom. Okay, now we have this thing, SS regression. What will be its degrees of freedom? Sorry?
1.
Yes. And why is it so?
Because SST is equal to SS regression plus SS residual.
Residuals. And degrees of freedom has additive property. So for residuals, our degrees of freedom were n minus 2, and for total sum of squares it was n minus 1. So the degrees of freedom of regression would be 1. Okay, now coming to this question, suppose we want to test the hypothesis beta 1 equal to 0 against beta 1 not equal to 0 at this alpha. So what my decision should be? So as we have seen, beta 1 hat, it follows normal beta 1 sigma square by sxx. Here we are not said, we did nothing is said about sigma square, so sigma square is unknown. Now since this follows normal beta 1 sigma square by sxx, beta 1 under h naught, it will follow 0, this thing. And we also have seen n minus 2 ms regression by sigma square to follow chi square n minus 2. And this one, they are independent. So from here, beta 1 hat by root over sigma square by sxx, this under h naught follows normal 0 1. And if we divide this thing, so our test statistic is this one, just a minute, this one divided by root over of this variable divided by its degrees of freedom, that is so this one and this one will cancel, this one and this one will also cancel. So our t statistic is beta 1 hat by root over ms regression by Sxx, which under H naught follows a T n minus 2 distribution. So if we have to compute the T statistic, what do we have? Beta 1 hat was half. MS regression was how much? 43.2. This is 43.2 divided by Sxx. Sxx was 160. So what is this value? Anybody calculate?
.2 is mean square regression or sum of regression?
Oh, sorry, sum of regression. So mean was how much?
43.2 upon 18.
43.2 by 18. Yes, this one. This comes out at as what? .4 divided by 160 square root of and 0.5 divided by 0.12. It comes out to something close to 4.167. Okay, anybody got anything else? Okay, so this is the value of my test statistic. Now my alternate is beta 1 is not equal to 0. So intuitively, if this is a t distribution with mean 0, so intuitively if beta 1 is not equal to 0, if I have to establish this fact, then my t statistic must lie in this part or this part, since it could be greater than or less than as well. So the critical region is this one, Tn minus 2 alpha by 2. This is the critical point such that above which this probability is alpha by 2. So if my t statistic values lies here or here, that is mod t is greater than Tn minus 2 alpha by 2, where alpha by 2 is the upper critical point, upper alpha by 2 point of Tn minus 2 distribution. I have to find what is this point. So I have a t table with me, so we'll consider these two-tailed tests, and our degree total level of significance is this one, alpha 0.05, and the degrees of freedom that I'm interested is in 18. So the upper alpha critical point is 2.1. So this is T.975. It means that probability any point less than this point is 0.975. 0.25% of, this one, T greater than 2.101 equal to 0.025. So we are looking at this point, 2.101. This is my critical point. Now here my rejection region was if mod t is greater than Tn minus 2 alpha by 2. So this point is 2.101 and our observed T is this one, 4.167. Since it is greater than this one, hence we are rejecting H naught. Any doubt? Hello?
Yes, ma'am.
Okay. So similarly, this problem is asking us to test the hypothesis beta naught equal to 0 versus H1 beta naught not equal to 0. So as we have seen, beta naught hat, this is also a linear combination of the y's which follows the normal distribution. So this was its expected value and this was the variance. So similarly, beta naught hat minus beta naught by this thing, this follows normal 0 1, again n minus 2 ms residuals by sigma square, this follows chi square n minus 1, and these are independent. So our test statistic beta naught hat minus beta naught by sigma square 1 by n plus x bar whole square by sxx divided by root mean chi square, it follows t n minus 2. This one will cancel, this one will cancel, and we'll be left with beta naught hat minus beta naught by root over ms residuals ms residuals 1 by n plus x bar square by sxx. So under H naught, this will become 0. So our final test statistic is beta naught hat by root over ms residual 1 by n plus x bar square by sxx. So how much will this come out to be? This is 0.5 by root over 43.2 by 18, 1 by 20 plus 5 square by sxx was 160. So this is how much? This is something, it's coming out to be 0.7 for me. And here again, the alternate hypothesis was beta naught not equal to 0. So we'll only reject H naught if T is greater than Tn minus 2 alpha by 2. This point was 2.1, and now we have our test statistic value as 0.7. So since this one is not greater than 2.1, we are going to accept H naught. We do not reject H naught. Is it fine? Is it okay?
It's not clear, no? It's back complicated.
Did you go through the lectures?
Not yet.
Okay, please go through the lecture once again. These all derivations have been given there. Okay, and there's this class note also. You can follow this one. Here also you'll find this derivation that, as I was explaining, I failed, but
Okay.
clearly it's given here how we are supposed to derive it. Okay, so I would request
Okay.
you to go through. I'm really sorry I couldn't do it here. And if you have any doubts, please post it in the discussion session. Uh, I'll try to answer it. So whatever I tried to explain a few sums. I hope this will be helpful in your assignments. And if you have any questions, please put it in the discussions box. I think I'll close the session now. Any other doubts? Okay. Thank you, everyone. Have a nice day.
Thank you.
Thank you, ma'am.
Thank you.